I could go back to the Design tab and I'll right click on the belt node and select Edit using Design Accelerator, and I'm going to go to this Calculation tab. Now back here on the Design tab I could tell it a different number of belts rather than one, but I'm going to go to the Calculations tab and I'm going to tell it to calculate the number of belts that would be needed if I have a 4 horsepower motor on the input shaft. And so I do calculate, and when I say OK to this, we see that put in 2 belts in here. We could also put in chain sprockets. So underneath the V belt is roller chain. Now when we do the roller chains, we do the sprockets in the same manner that we would do these pulleys, but it's just going to put a simplified representation of the chain that'll look something like this belt. One question that always comes up is somebody wants to do a real chain. When doing a chain, I would use one of 2 visual tricks. I would either just put a cosmetic texture that looks like a chain, or I would do a trick with an optical illusion where only one real link is moving, but it appear via an optical illusion that the entire chain is moving. If you try to put in the number of joints or constraints that would be required for a long chain, that will bring the software to its knees. So in a later lab I may show you how to do a chain. So your challenge on this one is to delete the pulleys and go ahead and create a mechanism with roller chain sprocket. When setting up a chain, it's the same steps of operation. So I'll select a roller chain generator. I will select the plane to center that sprocket, and I want my second sprocket to be down at this end and my first sprocket to be over towards this end. So I can drag those close to my position, and then I will do the fixed position by selecting geometry, and I'll select this cylinder that moves that sprocket to that location. I'll go to the second sprocket and I'll do direction driven sliding position, and I'll select this plane, and again we can drag the location, and it stops only where there would be a even number of chain lengths, and it's also based on the size of the chain that we selected, in this case a number 40 chain, and so I can decrease and increase the number of teeth on that sprocket. Let's increase this one a few, and I can set the rotation. I want to make sure that this doesn't interfere down here with the number of teeth that I put on here. Each one of these yellow circles represents a link, and somewhere here it will tell you, in this case 128 links of a number 40 chain, and if we wanted to add an idler sprocket in there, we could add an additional sprocket. I'll say OK to that. Now remember, we still need to connect these sprockets to the shafts, and also we need to constrain the axis of the shaft to the axis of the sprocket, and I've turned off the visibility of that sprocket, so I need to go find that z-axis, and then if I try to rotate this, I see that it doesn't rotate. So don't forget the last step. This is a sub-assembly, so you need to make this flexible, and now when I rotate one of these sprockets, the other sprocket rotates as well. So that's the challenge for you, is to create the sprocket assembly with the sprockets on the constrained to the drive shafts.